Hello. Oh my god. Hello. Welcome to a new problem. We're going to do maximum level sum of a binary tree. Number 1161. Medium problem LeetCode. So let's go solve this. But yeah, first things first, I want to say that this problem is very similar to this one problem that I just did yesterday, which was binary tree right side view or something like that. I forgot, but it is also a medium problem. And I did solve it both with depth first search and breadth first search. But for this part, but for this problem, we're only gonna do breadth first search. But I'll just go into like some things that I can think about while solving this problem in the matching phase. But let's just go ahead and understand it. So let's go read out the problem, get the input and output. So given the roots of a binary tree, level of its root is 1, the level of its children is 2, and so on. Okay. Return the smallest level x such that the sum. Return the smallest level x such that the sum of all values at all values of nodes at level x is maximal. Okay. Hold up, I gotta read that again. So return the smallest level x. The smallest level x. The smallest level x? Such that the sum of all values at node level x is maximal. What the hell? I don't get it. Can you just say like return level x such that the sum of all values of node level x is maximal? Is the max? I don't know, it's really weird. Oh, I don't have water in here. I have water in here. Well, I gotta think about that. Hmm. Hmm. Get it. I'm just gonna say that our input is just binary tree. Integer where x denotes x presents level of which has the max value of any level of all levels above all levels. Okay, that's just a note. I think that's pretty much what we're supposed to do. And then let's go over some examples, I guess. Let's ask some questions actually. I don't know why that ran, but I guess a question is like, what is the min size? What is the min size of? What is the min size of input binary tree? I'm gonna guess it's like 0. No, it's just 1. Okay. I would ask like what's the minimum value, but I don't think that really matters in my opinion. Unless you're coding like Java or something, I guess. I don't know. But yeah. So there we got the input output, took some notes, we asked some questions. Now I think we're fine to kind of do an example. Kind of showcase that we do understand the problem. Example, okay. Alright, so let's just make this really easy. Let's say we have, oh yeah, I really like how this looks. I really like how this looks. This is amazing. This is awesome. Alright, so let's say we have 1, then like 2. Oh wow, this looks really good. 1, 2, 3 and 4. We also have like a 0 here, right? So we're supposed to again return the value or level that represents or that holds the max value of all the levels in the binary tree. So let's just do some mental math in our head to kind of find which level has the max. Well, this is 1. This is value 1. This is value 5. 2 plus 3 is 5. 4 plus 0 is equal to 4, right? So we know that the max value is here, or the max level is here, because it has a value of 5 compared to all the other ones, right? Less than, and this is more than, right? And to note that the levels are one index, so 1 is level 2, level 3, and so on. So yeah, I think this is the whole thing. So yeah, that's pretty much it. So yeah, that's pretty much it. Yeah, I think that's pretty much it. That was one example. Hopefully that is a solution. So let's go ahead and match, right? So we could go DFS where we take in the node and the depth, and where we could have like list of sums. I guess I'm not sure. Will we have list of sums? Yeah, we would have list of sums. Yeah, I'm pretty sure we'd have list of sums, where we could just kind of like add. All right, so like, okay, so we already inputted 2 in the list, right? So now we go to the 3. 2 is already there in that index position, so we just add it to 3. Plus 3 is equal to 5, right? And then so on, right? And then just get the max, I guess, like a max variable, where we kind of like each time we input something, kind of get the max. I guess max is equal to like the max of like 1 or sum, right, that we do. That's something that's also we could do. That's one thing about. And this is fine. But I think I want to use this with the breadth first search. We're just taking the node, right? And then from there, would have a queue, slash deck. What else we would have? I don't think we would need to have a Oh wow, this is so good. Wow, this program is this program is amazing. So we won't need to have like a list, because since we're going through each level, right? We can have like a variable, so like max is equal to like 1 or it's equal to cur or sum, I guess, something like that, where we get the sum at the end, so we can just compare, right? Wait, this is so good. So max variable. Then we'd also need to do like a for loop too. To iterate through level in queue. Because we would need to basically say like what we need to do. We'd be like, okay, so for I, like I in range of this level, because once we get this in the queue, we're like, okay, this is the only thing in the queue until we get its left and right, right? If we get its left and right, then that means we're on the next level basically. So yeah, I think that makes sense. And then how would we save the we need a way to save the level. So maybe we could also do like an if statement. If statement to save level. So like if we find out that this is the max, if this is more than this, then we can just say, okay, update the level. So level 2 is now like the answer for that, right? So I think that's fine. So yeah, I'm pretty sure that's it. But let's go ahead and plan out how the code's gonna look like in pseudocode. So we're obviously gonna have a max sum variable is equal to I guess root.val. And then max level is equal to just 1, I guess. Because the min size is going to be 1. So we're definitely gonna have one default answer, which is just 1 is the max level, because the min input size is 1, and so if there's 1 node, then that means guaranteed 1 level. So yeah, so this is what we do. We initialize vars to help solve problem, and then we do right first search. So oh yeah, we also need to initialize our queue and stuff. So the queue is equal to collections is equal to deck, basically. Then we have to give it initial starting value because we're going to do like a while queue. So while queue is not empty, right? And so we have to say we have to give it the queue of root, right? And then let me think. So we need to iterate through the level itself. So we need to do a for loop, right? So I think we do it in here. So for, oh no, we can say like get length of level. So we can say how can I say this? So when we start off, right, we're also gonna have a level of, we're gonna have a length level of 1. So level length is equal to length of queue, right? And then we need to iterate through level. And then what I want to do here is I want to get some, compare some with current max. So I have to say for I in range of the level length. What do I want to do? What do I want to do? I want to get the levels. So let me think. Let me think. So I want to get temp sum. I want to have a temp sum, so temp sum is equal to 0, right? So this temp sum, I'm going to basically pop left of everything. So here we have just 1, right? So what we want to do is we want to basically pop that 1. So node is equal to pop left, and then I want to say if node, then what I want to do is I want to append it into temp sum. I don't want to append it. I want to increment it with temp sum. So temp sum plus equal to node.val, right? And then that's pretty much it. But then after that, what I want to do is I want to take the left and right of that node. So I'm gonna say, if that's the case, then we're also gonna add q dot append node dot left and q dot append node dot right. So we kind of get this in the list. So our list is gonna look like this now. So then we have 2 and 3, right? And then let's just skip that part first. We're not gonna iterate through that yet, but in the case where this runs correctly, we're going to get out of the binary tree, right? So I also want to compare sum with max and then compare level. Okay, then I want to say, in this case, so in the end, if temp sum more than okay, I kind of get why they say the smallest level x such that the sum of all values is maximal. Okay, so in that case, we say if temp sum is more than, we don't say more than equal to. If temp sum is more than max sum, then we're going to basically update level. If sum is more, if cur more than max, then cur max. We need to update level. So we need to update the level. So we say oh, we're not keeping count the level. I guess we can say per level to 1, right? And then if temp sum more than if temp sum is more than current max, then max level, or I can just say res. So res equal to 0 or just 1. Then res is equal to cur level. Then at the end, we just increment cur level by 1. Increment cur level. And then, is that it for the while loop? I think. Okay, so you append. You just keep on looping. Then once we're done with the level, we're going to check if the temp sum that we got from that level is more than the max sum that we have. Then if that's the case, then we're going to make the res equal to the current level that we're at right now. At the end, increment the current level. So yeah, I think this works out. And then once we're out of the while loop, once the queue is empty, we're just going to return res. So yeah, I think this plan works out correctly. Yeah, this makes sense to me. So what I'm going to do is I'm going to basically copy and paste this in LeetCode as a help me code, right? All right, so we're basically going to copy this whole thing. So first things first, in our plan, we're going to initialize our variables to help solve this problem. So we're going to initialize max sum, which is equal to .val. We're going to initialize our current level, which is 1 at all times. We're going to initialize result, which is default at 1, just in case. And then we're going to initialize our queue, which is equal to collections deck with the initial value of root. And then I want to do some breadth-first search. So we say while queue is not empty, we want to get the level length. So level length is equal to the length of the queue. And then once you get the temp sum, right? Temp sum is equal to 0. And then we're going to iterate through the level. So for I in range all the way up to the level length that we have right now, we're going to get that. Okay, what we're going to do is we're going to get that node, and then we're going to get it from the queue. I think this is pop left, right? Deck pop left. Yeah, okay, cool. So it's pop left, and then what we want to do, so if this is a valid node, so if node, then we're just going to add it to the temp sum. And then we're going to add in that node's next level, or left and right, which is basically the next level, which is q dot append, and we append node dot left and append its right. It could be null, so this is why we have this part here. And then once we're out of that for loop, then we should have the temp sum accumulated already. So we gotta say, so if temp sum more than max sum, that's the case, then we're going to say that max sum is equal to temp sum, and we're going to say that res is equal to cur level. And then once we're out of that, we can finally move on to the next level. So in the next loop or iteration, we're going to be on the next level. So to signify that, we're going to say cur level plus equal to 1, which means we're going to go on to the next level. And this whole thing keeps on going until the queue is empty. So yeah, that's cool. So yeah, and then we can just return res in here, and then now we're done. So this should run. All right. So pass 2 of 2. Let's see if it submits. Wrong answer on this one. It outputs. Can I use? One, two, three. Oh, okay. Should be 2. What did they say? Should be. What did they say? I didn't see. Oh, they expected 2. 1, 2. Why not 3? Oh, I get it. Okay. So this is 1. Oh, okay. Okay, so I think the min value does matter. So I guess the max sum could be I guess let me see. So max sum um could be negative infinity. Whoa. Okay, so it says it's I output 1. Not sure why. If temp sum exists, what I say if temp sum? Shouldn't I say like I don't know. Damn, I forgot why I haven't said that. Okay, this is the case. I put 4 instead of 3. Oh, I see why. Okay. Okay, so I say it's giving 4 because temp sum is equal to 0 when we go to the children, right? So if I say just none, if I say that temp sum is none, but then once you get in the for loop, temp sum is equal to, wait, hmm. Can I just say that? Is that right? I don't think that's right. Yeah, it's not right. So what can I say? What can I say? What can I say? Can I just say that? Hmm. Okay, so if I do 0, right, it's gonna stink. How do I have to do this? I know what it is, but I just can't figure it out. Okay, so if they're all null, hmm. Can I just say that if temp sum is equal to 0? It just makes sense because they're all null, right? It would be equal to 0, but there's also a case where it does equal to 0, and that's like, Dude, this is making my brain hurt. I can say like I can say like if no dot left is null, then don't add it, right? I can just say that, to be honest. So I can just say that. So just say this. Then if no dot right, then append. I'll run, right? Yeah, I mean it does work like that, but like I mean, I don't know. That's very simple, but like I was just thinking about way different ways to solve it. But yeah, that took a long time to debug. I was just thinking about like what to do and stuff. So yeah, so to review its complexities for time, it is O of n because we go through each node once. Well, not anymore because of if no dot left and no dot right. But I think that's fine. It's whatever. And for space complexity, I would say this is O of n because we're using a queue to solve this problem.